Hi, today we're going to be talking about logarithmic growth, and there's a few key things that we need to know when we're talking about logarithms. So a logarithm is basically the inverse of an exponent. So if you have something like 2 to the third, we know that 2 to the third is equal to 8, right? Because it's 2 times 2 times 2. Well, sometimes you won't know what an exponent is. And sometimes it's easy when you have like 2 to the x equals 8 because you sometimes know these things, but when it's something crazy, it's a little bit harder to find out. And a way to find out is our logarithmic functions. So the way that I like to explain it is I have the base to the exponent is equal to the answer. This is for our exponents. But for logarithms, and also, sorry, I misspoke earlier. Logarithms are not the inverse necessarily. It's just a way to find our exponents. Inverses would be more technically like roots. But so we have b to the x equals a. That's the same as writing log to the base to the answer is equal to our exponent. And this is a little bit tricky to get used to, but eventually you will get used to it. It just takes a little bit of practice, and you'll get it eventually. It's all good. Now, I think it's easier to explain a little more if we have examples. So I have some of these pulled up. When you see ln, that is the exact same as log base e. Now, log base e, e is a number that is seen in nature a lot, and you'll see it throughout math a lot. You don't need to worry what e is necessarily for this class. All you need to know is that the ln stands for natural log, stands for log base e. So we have ln of x is equal to 17. We know that this is our exponent, this is our answer, and we know that e is our base. And we don't even need to plug this into our calculator. We're allowed to do e to the 17. It is equal to x. And that would be our answer. Now, you'll see questions like this where it's like crazy, intimidating numbers. Really, it's not as scary as it looks. And you don't need to really even necessarily pay that much attention to some of the crazy science stuff that it's saying. All we need to know is we have our equation, so we have our pH is equal to negative log of H plus, and H plus is our hydrogen ion concentration. We don't care about the hydrogen ion concentration or the H plus. H plus could be replaced with X, and it would work just the same. The plus and the H is sort of where people get tripped up. So we know that battery acid has a pH of 0 and lemon juice has a pH of 2. We want to compare the two and see how much more acidic battery acid is than lemon juice. So let's say battery acid for 0, we need to do two different equations. Battery acid is equal to 0. Lemon juice has a pH of 2, so 0 is equal to negative log. I forgot to mention, if you have a log with no base, just assume that it is 10. We've decided that a log with no base is 10. Negative log, and then H plus, and we want to solve for H plus. So this is the same as, well, before we convert it, we probably want to get rid of this negative. We can divide it by 0. 0 divided by negative 1 is equal to our 0. So log base 10 to the 0th is equal to our answer, which is H plus. So 1 is equal to H plus. That's as acidic as it can get. So this is for battery acid. And lemon juice has a pH of 2. So 2 is equal to negative log, H plus. We can divide by negative 1. So negative 2 is equal to log base 10 h plus, and which can be written as 10 to the negative 2 is equal to h plus, which will give you 1 over 100. We want to see how much more battery acid is in lemon juice, so we can put the 1 for battery acid over, well, I think we can do the 1 over 100. This one's a little bit more tricky, the next part of the problem, where you're trying to determine how much more acidic it is than the other. Let me double check. Okay, so I understand now. We want to know how much more acidic the battery acid is than our lemon juice. And we can figure this out by dividing the hydrogen ion concentration of the battery acid, the more acidic substance, by the concentration of our lemon juice. So it's going to look like, I'm going to get rid of this for a minute, 10 to the 0 over 10 to the negative 2, which is going to, since we have a negative 2 on the bottom, we can flip it up to the top. So 10 to, and 0 minus 2 is equal to minus 2. 10 to the second is equal to 100. So it is 100 times more acidic. This one has the same problem of looking pretty complicated and intimidating. This looks like a really long problem, but it's actually okay. It's manageable. So we have a psychologist who's studying the capacity of the human mind to process information, and he's found that the percentage of information one particular participant can recall after T months have passed can be, modeled by the following logarithmic function. Now we want to plug in our 8 for T, so 90 minus 23 ln T plus 1, plug in the 8 for T, 8 plus 1. You can plug this into your calculator. It works just fine. Use the definition of the logarithm to find the missing value. So we know that our base is b, our exponent is 2, and 169 is our number. So we can square root this, both sides. And 169 square root is, I believe, 13. 13 squared is 169. Yep, so our answer is B equals 13. The sound intensity is measured by the formula decibels is equal to 10 log I over I0. The chirping of a bird is 1,585 times as intense as the threshold of sound. How many decibels is a bird chirp? Now, this one is a little bit tricky, again, because it's got the kind of confusing variables, but a lot of these can just be replaced by x. Now, I sub 0, I naught, I think is what Keith refers it to, is always going to equal 1, because some people at it's science.com, not actually science.com, but some people, when they were deciding sound frequency, decided that the lowest sound that a human, I believe baby, can hear is going to be 1 on our decibels, or not decibels, our sound intensity. It's not going to be 0, because if it's 0, that means there's nothing going on, but it's 1 if there's something going on. And then our I is just going to be our intensity. So we have our decibels. We want to find out our decibels of the bird chirp. Decibels is equal to 10 log times 1,585 over 1, basically. Yep. We want to divide both sides by 10. So dB is equal, dB divided by 10 is equal to logarithm, and then our crazy number. And then we have 10 to the dB over 10. Hold on, wait a second. Give me just like 2 seconds to rethink this one. Okay, my bad. I was overcomplicating things. We don't need to divide by 10 or anything. All we need to do is plug this into our calculator, and it will give us our decibels. Yep. And then use the definition of the logarithm to find the missing value. Again, so our base is 5. Our exponent is x is equal to 1. We know that anything to the 0th exponent is equal to 1, so x is going to be equal to 0. If you have any questions, please let me know. I'll answer them as soon as possible. And yeah, have a good day. See ya. Bye.